Hey guys, today we're going to look at linear systems, and this is the first part of the notes of section 1.6. And the essential question for the day is, how can you find and represent solutions of systems of linear equations and inequalities? And some of the vocabulary is system of linear equations, system of linear inequalities, solutions of a system of linear equalities, and an inconsistent system. So, here we go. First thing we're going to look at is, what is the solution to the system of this set of linear equations? And to do that, we want to put each equation in the form of y equals mx plus b in order to graph these. So we would have, for the first equation, x plus 2y equals 3. We would have 2y equals negative x plus 3, and y equals negative 1/2 x plus 3/2. And to graph that, we have a y-intercept of 1.5 and a slope of negative 1/2. So up 1/2 to the left, or down 1/2. And we could connect that line, which I do so well without a ruler. Our second equation, x minus 2y equals 4, negative 2y equals negative x plus 4, so y equals 1/2 x minus 2. So we have a y-intercept at negative 2 and a slope of 1/2, so up 1/2, up 1/2. So we can see that this system of equations is intersecting somewhere right here, but it is not an exact value, so we need to go ahead and see what we can do to make it an exact value. And in order to do that, we can use substitution, which is a pretty easy way to go for sure. So if we take our two equations, x plus 2y equals 3 and x minus 2y equals 4, and we solve this equation for x, we can take that quantity and sub it in for x in the other equation. So we would have 3 minus 2y equals 4. Combining our like terms, negative 4y equals 1, or y equals negative 1/4. Once you have your y value, you just go back to your original equation that you used to substitute, 3 minus 2 times negative 1/4. So 3 plus 1/2 is 7/2. So our point of intersection or solution is 7/2, negative 1/4. And if we look back up to our graph, 7/2 is 3.5, negative 1/4, and that looks about right.